we'll discuss about the different deck levels and the boat landing. Boat landing is very important factor and very important terms used in offshore platforms, and you will hear this term many times actually. This boat landing is normally used in case of any emergency. So this boat landing, it has different levels, upper level and the lower level. Again, it is with respect to the LAT, lowest astronomical tide. So from that level, normally the lower boat landing, the level 2, it is 2.89 meter above the LAT, and in some companies it is 1.84 meter. So it depends, company to company and standard to standard. And the upper boat landing, it is 3.89 meter from LAT, and some companies is 3.59 meter from LAT. So it again depends company to company. And this boat landing, the main objective of the boat landing is in case of emergency you have to reach till this boat landing, and boats will be available there, so you can take those boats and you can just escape from there. One thing. Second thing, this boat landing is always across wind. Across wind, for example, if the wind direction is north to south or south to north, this is the wind direction, it means the wave motion will be in this direction. So in that case, the boat landing will be provided across it, like east or west side of the platform. I'll explain you in the next slide. In this next slide, you can see this is the prevailing wind and this is the point north, and in this prevailing wind you can see the boat landing is provided across this. And this is north, this is south, east and west, and the boat landing is providing east and west because the wave motion will be in north and south. Here you can see the prevailing wind here again, and this highlighted portion is called the boat landing. And as you can see here, these are the access ladder, and these ladders going down till the boat, and these are the overboard ladders. It is reaching to the boat, and these are west side boat landing, this is east side boat landing, and it has two elevation as you can see over here, 3.89 meter top of grade, and here 2.89 top of grade. This is the upper and this is the lower boat landing. And from this boat landing it is connected to the you can see the stairs, and you can go up to the boat landing level, and it is connected with the cellar deck, and so on. The different elevation will be there, so I'll explain in next slides. So in the east side again the same thing is there. You can see the overboard ladders, these are connected, you can say sea level, where your boat will be there, and you can simply land it on the top of the boat. So you can see there are different ladders are there. Ladder 1 is here, ladder 2 is again over here, and ladder 3 is over here. So ladder 4 and 5 over here. So this is the main and very famous term, boat landing, and all the offshore platform, it's very common term and common arrangement from the boat landing, and many people, they don't understand the concept of the boat landing, why it is required, and in which direction we have to provide the boat landing in case of with respect to the prevailing wind in case of emergency. Here you can see this is the overall side view of the platform, and this highlighted portion you can see the upper boat landing and the lower boat landing. The upper boat landing elevation is this, and then staircase is there, and then there is a lower boat landing, and then you can see the ladders are there. So these ladders will reach to the sea level, and then you can through this ladder you can connect it with the boats. So, and these are available on each side of the platform, east or west, it depending on again the wind direction. So rest of the levels and things we will discuss in next slides. So jacket walkway, after the boat landing, we have started from the bottom of the jacket, and after discussing the J tubes and the risers and the jacket details, conductor details, now we are going up one level up. So first we had discussed the boat landing, and after the boat landing this is the next level, that is called the jacket walkway level, and this elevation is 5.7 meter, or in some companies 6 meter from the LAT. At this level normally you can walk without any problem. At this level considered to be a safe, and 5.7 and 6 meter from the LAT, quite high level from the splash zone. So you can see this jacket walkway, and this is the level, and this level is again connected through the staircase to the lower and upper boat landing. This level is easily accessible, and it is connected with the cellar deck. The components in each level and each deck I will discuss in 3D model. So cellar deck normally it is at 7.5 meter high from the LAT, and in some companies is 10.86 meter high from the LAT. So it depends again standard to standard and company to company, but this is the first level considered to place any equipment on the deck. When lower than that, normally we don't place any equipment. So this is the first level. Normally we placed any process equipment, and normally we have the slope tank and the pumps at this level. So but those things I will discuss in 3D model. So here it is, you can see this is the level, and you can see one tank is there. This is called slope tank, and piping connected over here, and there are pumps as well, slope tank pumps. So the details again we will discuss later on. Here I am just giving you the introduction and the idea of different decks, where they are located. After the cellar deck there is a main deck, and the main deck it is normally 12 meter high from the LAT. You can say the difference between the cellar deck and the main deck, it's approximately 4.5 meter, but it all depends on the standard to standard and company to company. As you can see, this is cellar deck, and from the cellar deck this is the main deck, and from the cellar deck it is 7.5 meter, and this main deck, if you see, the elevation is 12 meter. The main components you can see, main process component and electrical components, and many things are there at this level. That's why it is called the main deck. After the main deck there is a drilling deck or wellhead deck, and this drilling deck or wellhead deck actually it is 15 meter from the LAT. It is 3 meter high from the main deck, and as you can see, all the Christmas tree components like different valves are there. So I will discuss in detail about the Christmas tree, like subsurface valves and surface valves and the crown valves. All the complete details of the Christmas tree will discuss in 3D model review. This is the area where the rig will come, and normally they will do the rig work over. Rigging activity, it is normally done at this elevation, at this level and in this area. After that, the drilling deck, there is a mezzanine deck, and this mezzanine deck it is 16.5 meter from LAT. Again this elevation could vary slightly here and there depending on the different standards and different companies. So this elevation, as you can see, it is right below the heli deck and right above the mezzanine deck, and the elevation difference, as you can see over here, it is 16.5, and the wellhead deck is 15. So it's only a 1.5 meter the elevation difference between these two levels. And main electrical equipments you will find over here, all the transformers and all the utilities you can say, and you will find it on this level, and all electrical utility equipments will be kept at mezzanine deck. After the mezzanine deck, the heli deck, it is again 21 meter from the LAT, and as you can see, it is on the top. And we'll discuss heli deck in detail, its main components. It has a separate details related to the aviation, the component required on the heli deck, and the lighting and floodlights, and many things are there on the top. As I have discussed this, the heli deck, normally the helicopter approach is from the crosswind. If the wind direction is north to south or south to north, the prevailing wind direction, then the helicopter approach will be normally the crosswind from east or west. And as you can see, this is called the obstruction free gradient zone, and normally it is 5:1 slope is there, and it is called the helicopter fall free gradient or fall free space. There shouldn't be any facility underneath to avoid any damage in case. So it will fall at this gradient at this angle, so we have to keep this space free on both this side. As you can see, the heli deck over here, this is the 180-degree sector, this is 210-degree sector, this is sea level. So the heli deck, normally it is designed in two shapes. one is called the square shape, other one is called octagon shape. And this is that gradient, that falling gradient of the helicopter. When helicopter will fall, there should be any drop object, I mean any equipment should be there that can hit by the helicopter, and the disaster will be more as compared to the free space. So within these 210 sectors, no objects above this line. So this is what it is called, the landing area of the helicopter, and no structure between these lines in 180-degree sector. So in this sector there should be any checked or any structure, anything like that. That's why the area in which the rig structure is permitted in 180-degree sector. So this is the complete structure, and beyond this there is nothing. This is sea level and no structure between these lines in 180-degree. And we'll discuss the heli deck and the other parts of different decks in the 3D model in details.